Solve systems using elimination. Over here on the right, you can see the two situations we've covered so far. If we have two equations that are each y equals, like this black and red ones, we can graph it and just simply find where they cross. We could also use the table function to see when the tables themselves end up crossing. If we do not have them in a y equals format, then most of the time what you will have to do, like these two equations here, is you will have to use substitution. And that is only usable if one of our equations, in this case the green one, has a variable isolated on one side of the equal sign, as this x is on the left. Today, we're going to answer the question, what do you do if both equations are not in y equals form and they're both in standard form instead, where they look something like this. 2x minus 3y, I'm just making these up, is 6, and 4x minus 7y is 10. How in the world do we eliminate one of these variables so that we can just have our one variable again and use SADME to figure it out and then get the other one? Well, it's funny that I use that eliminate word. That's by design. We have to use a separate method called elimination. And here's how it works. If I can get my x above each other or my y's above each other, notice how they're all lined up, that's again by design, to be the opposites. So if 4x could cancel with negative 4x, so let's just assume that this is a really nice, easy problem here. And that it was already magically, and we will get some like this, so don't worry, negative 4x. We can basically add these in the same old school way you used to add like 17 plus 13, and you'd go, oh, that's 10. Carry the 1, 1 and 1 and 1 make 30. Okay. We're going to do that same thing here, where 6 and 10 are going to make 16. Negative 3y and negative 7y will make negative 10y. And then check it out. Negative 4x plus 4x, oh, that equals 0, which means that's been eliminated. And now all of a sudden, I've got a super easy equation that I could divide and solve for y. Elimination ends up being easier to solve for the first variable, but then tougher for the second one. Because once I get y, I have to use parentheses and plug it back in either one of these equations. For y, rewrite it, and then go through the same steps I did in substitution. I got to distribute, solve for x, and then I have my answer. What about, though, let's return to our unfortunate world, just going back in time right now, where this was my answer. What do I do now? Oh, crap. Okay, well, in this world, we're not totally screwed. In fact, we're not screwed at all. We just have to do one more step. I have to decide, is it easier to get my y's to be opposites to cancel or my x's? Well, my y's are both negative. That's a problem. I want one to be negative, one to be positive. And also 3 and 7, those are ugly to try and get to be the same number. I'd have to make them 21, and then I have to change both equations. Well, instead, for x, I know I can make this negative 4 to cancel with this positive 4 if I was to just multiply this number by negative 2, because 2 times negative 2 is negative 4. Now, you can't just do that in math and be fine. That would change this entire equation. What I can do, though, in the same way that I always say you have to feed every single sibling the exact same amount of food, just like I'm a triplet, the goldfish example, you have to do the same exact thing to every part of an equation on both sides. So if I'm going to multiply 2 by negative 2, I have to multiply this entire thing by negative 2. And I got to do this rainbow method I'm talking about, where I distribute. And now with 3 terms, it's starting to look more like a rainbow. And I could rewrite this below as in red, 2x and 2x would indeed make negative 4x. Yay. In green, negative 2x and negative 3x would make positive 6x. And then finally, my numbers here, negative 2 times That's a little confusing. I should have probably made that a dot. Negative 2 times 6 is in blue. Negative 12. And now I can do the same thing that I just did before. Cancel there. This becomes... Why did I write an X down there? Jeez. This is supposed to be a Y. Okay. I could hear you guys screaming at your screens. Yeah, 2 times negative 3y is positive 6y. Yeah. Okay, so negative 7y plus 6y is negative 1y. And then that would equal 10 minus 12 is negative 2. And then we divide, solve for y. Okay, that's the idea. So we have to either see, does it cancel automatically, or do we end up having to multiply some number times one of the equations, or both the equations potentially, to get them to cancel? I hope you have your pencil ready and paper ready, because we will need them for sure. So let's dive into it and see what we got. Knowing that I am a very graceful teacher, I know that this is a complicated set of calculations. This could take a long time. So instead, just like with substitution, I've given you only a few of these problems, and first, given you ones that are simpler. And number 1 says this. Notice they're already lined up. We've got our x's on top. We got our y's. This is, I guess, a little bit off center, but the numbers are on top too. And we got to say, which variable is easiest to eliminate in the above system? Well, our y's are 4y and negative y, so we could multiply the whole thing by 4 to cancel there. But look at our x's. X and negative x, oh, beautiful. It's already opposite. We don't have to do anything. Meaning, what type of problem is this? Is it a 0 step where we just have to cancel? Is it a 1 step where we have to multiply one of the equations? Or is it an ugly one where the x's and y's, you have to multiply both equations by some number to get them to cancel? The answer? It's a 0 step. If we just add them, the x's cancel, and we're good to go. When it comes to elimination, those are by far our favorite problems. Just like number 2, because look, 4x and x make 5x, but the y's cancel. Negative y plus positive y is 0. So it's y, and it's a 0 step again. Now we have one that looks very close to a 0 step again, but we remember we want this to add to 0, and even though these are the same exact number, negative 6 and negative 6, you can see on my calculator on the right, they don't form 0, they form negative 12. Instead, we want one to be negative 6 and the other to be positive 6. So we don't have to do that right now, thankfully. We have to tell ourselves, okay, that would take 1 step to cancel the x's. I'd have to change this negative 6 to a positive 6, so multiply this whole line by negative 1. And the y's, positive 11 and negative 6, it would take 2 steps to make these opposites. So x is simpler because it would only take 1 step instead of 2 steps. All right, number 4 is going to be a very similar thing, but for y. The x's, getting 10x and 9x to become opposites and negatives, would take 2 steps, or at least 1 negative and 1 positive. The y's, it would take only 1 step to make this a positive 4y to cancel with the negative 4y. And I'd have a choice of whether I wanted to change the top equation or the bottom equation. All right, 4 problems done. How many do I have left? I have 10 total. Okay. But I don't have to eliminate yet. Number 5 says negative x and negative 3x, negative 2y and 3y. Okay. To solve this equation, the y is going to be 2 steps, but the x, remember if we don't have a number like it says negative x, that's the same thing as writing negative 1x. And if I want this negative 3x on bottom to cancel with a positive 3x on top, I can make that work. I would just have to multiply this whole thing by, well, let's think about it. I want 3. I've got negative 1. So it's going to have to be a negative. And then what number times 1 gives me 3? Oh, 3. So if I multiply that whole row by negative 3, then the x's would cancel. And so all I need to write is that I would multiply this first equation by negative 3. Again, we're not having to do that actual multiplication right now. We're just going to have to say what we would do if we were solving this problem. The same thing with 6. Y's are 2 steps. I'd have to change one of these to a positive and then get these numbers to be the same. But x's, 6x would cancel with negative 6x. If they're already opposites, so all I have to do is multiply this second equation, or the bottom equation. I want this to be negative 6, it's negative x, so let's multiply it by 6. I didn't have to say a negative because they were already opposite signs. And wow, I'm looking at my screen right now and I see so many 6s. It's crazy. All right, are we ready to do a real one? We are. All right, number 7. So we're going to do 4 real problems. Do we have our paper out? Ready? I hope so if you've gotten this far, and I hope you have. I'm going to do what I did last time with substitution. I'm going to write them out, and then I'm going to go into my full white screen mode, open up my whiteboard, and solve. So I'm going to recopy this up here. Okay, which means I don't even need the other equations anymore. Remember our old school elementary, line them up and add. 10 plus 4 is 14. My y is already canceled, so I can just get rid of them. 1x and 1x, remember we could put 1s there. 2x, all this lines up perfectly. Divide by 2 with a little sad me action. X is 7. Oh my gosh, that was fast. I love these when they line up. But now we have to plug it in to solve for y. Well, we've got a choice here. We could either plug in here or here. I like to always choose the one that has fewer negatives. This has a negative y. This has no negatives. So it's simpler to just use the top equation. I know that x is 7. Why is this x and not y? Because x comes before y in the alphabet, in the same way x comes before y in my ordered pair. So I'm going to rewrite this top equation. 7 plus y is 10. I could even make sure to use parentheses, but there's nothing in front of it, so it's fine. Then all I have to do, a little sad me, subtract 7. Y is 3. So my answer is 7, 3. I actually prefer elimination to substitution, even though that second step can be annoying, because I like this idea of like manipulating equations to cancel. There's just something gratifying about it. Okay, number 8 also looks like a 0-step equation because the x's can cancel. So even though I've given you 4 problems instead of 3, these first 0-step ones are very nice. You're welcome. Then we'll give you one that is not 0 steps. All right, whiteboard it up. The x's will cancel. 4y plus, put a 1y there, is 5y. And that equals 16 and 9 is 25. Divide by 5. Y is 5. Let's plug it back in. Anytime we have a choice, so down here, I not only have no negatives, but I have nothing in front of my y. It's just a 1y. That makes it much easier, because now I have 4x plus y is 9, and I could simply subtract 5, and then 4x is 4, divide by 4. 4 divided by 4, x is 1. And I could eyeball this real quick. Negative 1 times 4 is, or negative 4 times 1 is negative 4. Negative 4 plus 20 is 16, check. And 4 times 1 is 4. 4 plus 5 is 9. Perfect. No, I'm right. Don't even have to use my graph. 1, 5. The beauty of algebra. It takes some time to do, but it's so powerful to be able to check your work. Some of my students really like guessing and checking, or guessing and adjusting. That works on some of these because I'm nice and I give integer answers, but it's always best to do the math behind it, because if you don't and it's some sort of nasty decimal, you'll never guess correctly. All right. We do not have a 0-step equation here. Dang. Sad day. All right. Negative 2x could cancel with positive 2x. That would take 1 step. I like this better, though, because this is all a bunch of negatives. This is a bunch of positives. I can have my 4y cancel with negative 4y if I multiply this whole top by negative 2. Then, let's do the rainbow distributive property method again. I'll try and keep my colors exact. So in red, I've got negative 2x. All right, I've been confusing myself so much. I'm going to put a dot. This is why dots exist for multiplication, when x's mean the variable x instead of multiplying. There we go. Now I'm not going to get confused, hopefully, anymore. All right, negative 2 times negative 2x in red becomes positive 4x. And notice I can just write this right below it. And then in orange, we have negative 2 times positive 2y. That is the whole inspiration for this. Negative 4y. That's going to cancel beautifully. And then we have got to not forget our blue section there. Negative 2 times positive 2 is negative 4. Once we have cancellation on our y's, now we can just add vertically. 4x minus 1x is 3x. And that equals 7 minus 4 is 3. Oh boy. 3 times what is 3? I don't know. Divide, it's 1. A very, very complicated problem we made simple. Now we're going to plug that 1 back in. We have a choice on that. I am going to choose the bottom equation. They both have a negative, but x is simpler than 2x, so I'm going to replug it into this one. So I've got negative, instead of x, I'm going to write it in 1, plus 4y is 7. So I'm going to add 1 to both sides. That goes away. 4y is 8, divide by 4. 8 divided by 4 is 2. If I eyeball this real quick, I get, let's see, negative 2 plus 4 would be 2, yep, and negative 1 plus 8 would be 7, yep, okay, 1, 2. All right, and we have just one problem left. We have yet to make a mistake on this. Hopefully I did not jinx it. Number 10 is a one-step equation, but I was hoping there'd be one of these. You're going to see what I'm talking about in a minute. Okay. 2x minus 3y is negative 1. Negative 11x minus 3y is 64. Check this out. Even though these don't perfectly match, they're not opposites. They're close. All I'd have to do is change one of these to a positive 3, right? I could multiply this whole thing by negative 1, or as a shortcut, I could just change all 3 signs. So check it out. Positive 11, positive 3y, negative 64. Boom. Now the y's cancel. 2 plus 11x is 13x. And 64 and negative 1 make... Or is that a negative 64? Uh-oh. It must be. It must be, because that's the only way it's going to be a... That's the only way it's going to be a decimal. Because I know that negative 65 divided by 13 is negative 5. Okay. This negative combined with the straight line I drew, and that became very problematic. But I think I solved it. All right, then we can plug it back in. Anywhere for x. Let's do this top. 2 times negative 5 minus 3y is negative 1. We got to do a little distributive property. 2 times negative 5 is negative 10. Minus 3y is negative 1. I think I'm already regretting it plugging into this equation because I've got the negative in front of the y, but it's too late. Can't go back now. Negative 3y is 9. Divide by negative 3. Y is 9 divided by negative 3 is negative 3. Let me just eyeball this. 2 times negative 5 is negative 10. Negative 10, a negative 3, and negative 3 make a positive 9. So negative 10 plus 9 is negative 1. Check. 11 times negative 5 is negative 55. Negative 55, 3 and negative 3 make minus 9. So negative 55 minus 9 is negative. That's definitely a negative 64. Yep, negative 5, negative 3. Whew. They are all not this difficult, obviously. But this one is tedious. The calculations around it individually are not that bad, but it's many steps, and if you do multiple problems, aren't you glad that I didn't give you 10 like that last group of 4? All right, submit. 100%. That feels great. Hopefully you got through it the same way. You do have other methods to fall back on if you need them, but I really hope that you wrote it out. You did it with elimination. If you did, high five yourself. Go get yourself a treat. You earned it today. You've learned a very valuable mathematical skill that's going to come in handy when you take complicated tests like the PSAT, ACT, SAT, other college entrance exams. We've learned graphing. We've learned tables. We've learned substitution and now elimination. We will have one final little review assignment that goes over all of them next time. Until then, much love. Have a great day. Bye-bye.